All right, lesson 10.6 is the probability of independent and dependent events. Okay, so before we get too started on this, I wanted to go ahead and spend some time reviewing. So if you remember, it says Wayne Township is opening a new school. From a list of 15 candidates, how many ways can a principal and an assistant principal be selected? So if you remember, when I'm looking for the number of outcomes, my possibilities are permutations or combinations. Permutations, the order is important. Combination, the order doesn't matter. So we got to take out those repeats. And one clue that I'm looking for is I'm putting these things into positions. Okay, so I want to know principal and vice principal. So whenever I'm putting them in positions, remember, it's a permutation. So 15 times 14, and I find out my answer is 210. So question number 2, it says Wayne Township is opening a new school. From a list of 15 candidates, how many ways can they hire 2 math teachers? So it doesn't really matter the order because we're not putting them in specific positions. We're hiring them as a group. So in this case, I'm still going to do 15 times 14, but since it is a combination in this case, and the order is not important, I'm going to divide by 2 factorial. So 210 divided by 2 gives me an answer of 105 different ways that I can come up with that. Okay. Number 4, it says a card is randomly drawn from a standard 52 card deck. What is the probability of getting a king? Well, if you count up all the kings, you find out that there are 4, and it goes over our possibilities. So 4 out of 52 or 1/13. Okay. And question number 4 says a card is randomly drawn from a standard 52 card deck. What is the probability of drawing a 2 or a heart? So remember, find the probability of getting a 2. So we find out that we've got 4 2s out of 52. There's that word or again, which means we're going to add how many hearts? We have 13 out of 52. And then we have to take out any repeats. So minus 1. Gives us 16 out of 52. Reduces to 4/13. Okay. So here's basically what we're looking at on independent events. Independent events is the occurrence of the first event has no bearing on what happens in the second event. So in the example, it says if you toss a coin twice, whatever I get on the second event has no effect what happens on the second event. Okay. If I throw a coin and then toss a die, what I get on the die doesn't matter what happened on the coin. So that's called an independent event. Okay? So the probability of independent events, basically all you're looking at is the word and. So we're going to do this, and then we're going to see this. And whenever you see that word and, you're going to multiply. Okay? So let's take a look at a couple of pretty basic and easy examples. So in the first one, it says the probability of A happening is 0.1. The probability of B happening is 0.8. So since that word and exists, I'm going to simply multiply them. So 1 times 8 is 8 and 2 decimal places. So my answer is 0.08. Okay. If I have a missing probability, so in other words, the probability of B is 0.5. The probability of A and B happening is 0.25. Well, if you remember, if I take the probability of A happening times the probability of B happening, that's going to equal my 0.25. And I can simply divide. So 0.25 divided by 0.5 gives me, so the probability of A happening is going to be 0.5. Okay. Fractions work very, very similar. You just have to remember when you're multiplying fractions, probability of A and B happening, we're going to multiply them. So 3/5 times 2/3, I can cancel, and I get 2/5 is my probability that that'll happen. Okay. When you're dividing, remember, if you divide, remember we're going to take 3/10 because we're going back the other way. We're going to divide it by 4/5. So 3/10 times, we got to flip it, 4/5 to 1. So I get a probability of 3/4 for B. Okay. All right, so let's take a look at some word problems. In example number 1, it says a bag contains 3 red marbles, 7 white marbles, and 5 blue marbles. Okay. Now these are actually known as dependent probability, because what happens the first time, what happens the first time does, let me rephrase that again. What happens on the second draw actually does depend on what we did on the first draw. Okay. And there's a couple of key things that you need to look for, whether you need to replace that thing. Did I pull out the wrong thing? Did I really not want it after I pulled it out? So I'm going to replace it. So those are usually some questions that we're going to ask. So we do know the bag contains 3 red marbles, 7 white marbles, and 5 blue marbles. So in A, we want to know what is the probability of drawing a red marble followed by a white marble with replacing the first one. So first of all, let's just take care of the first event. So the first event is, what's the probability of drawing out a red marble? So we get a red marble, we're going to get 3 out of our total. 3 plus 7 is 10, 5 more makes it 15. So we have 15 possibilities. Okay? Now, the second event, we're going to pull out a white marble. But we're actually going to take that first marble and put it back in the jar. So the probability of getting a white marble now is 7 out of, and we still have 15 marbles in the jar, because remember we put that the first one we drew back. And we're going to multiply. Now it does help if you do some canceling. So you find out that your probability of that event happening is 7 out of 75. So part B is, what is the probability of drawing a red marble followed by a white marble without replacing the first one? Well, our first event is getting a red marble. So we've got 3 out of 15 marbles that we can do it. So we pull out the red marble, we keep that marble out. Now how many marbles are left in the drawer, or in the jar? And that is correct. We have 14 marbles left in the drawer, or I'm sorry, in the jar. We have 7, so this times it's 7 out of 14, because we left that first marble out. Okay, we can do some canceling, and we find out that that drastically changes our probability if we don't put that first one back in the bag, and we get 1/10. Okay, so let's take a look at the next example. The next example says a bag of Skittles contains 8 red, 7 blue, 4 green, and 6 purple. So go ahead and try this one on your own. It says, what is the probability of drawing out a purple Skittle followed by a red one, and we're going to replace the first one. Okay. All right, so let's go ahead and take a look at this. So first of all, we got to find out, okay, what's the probability of getting a purple one? And we find out that it's 6 out of, you got to add them up. 8 plus 7 is 15. 4 more makes it 19. 6 more makes it 25. We know we're going to multiply. We're going to replace the first marble, which means we have 25 left in there. I know it's a multiply because I don't see the word or. That's the only way it usually indicates that we're going to add. And then we want to, on the second draw, after we put the first Skittle back in, we're going to get a red one, and we have 8 red ones. So we can multiply. No canceling on this one, unfortunately. And we get 42 out of 625. Okay. So go ahead and do part B. Part B says we've got the same Skittles in the bag, but this time we're going to pull out a purple marble followed by a green marble, and we're not going to replace the first one. All right, so let's find out purple marbles. We've got 6 again out of 25. We are not replacing the first one, which tells me that we've only got 24 Skittles left in the jar. And we've got 4 green ones, so it's going to be out of 4. And this one we can do some canceling. And then the 6's cancel, so we end up with 1/25. Okay. C is same scenario, but this time we're actually going to have 3 draws. A bag of Skittles, or we're going to draw 3 Skittles. The probability that the first 2 Skittles are green and the last one is blue, okay, without replacement, which means we're not going to put the Skittles back in there. So first one is, first 2 Skittles are green, so I have a 4 out of 25 chance of getting that green one. I'm going to multiply because there's no or in there. Actually, this one has the word and in it. So in the second draw, though, I don't have 4 Skittles left in the jar because I pulled that one out. I only have 3 out of 24. Okay? And then on the last one, I want the last one to be a blue one. And I do have 7 blue ones because I haven't pulled any of them out. But I only have 23 in the jar. Okay? So if I want to do some canceling, this gives me 1, 8, 1. That one goes to 2. And then I find out I have a 7 out of 1,150 chance of that specific event happening. Getting a green one, followed by a green one, followed by a blue one. Okay? All right. So example number 3. Now we've made this one a little easy on you. It says, you're playing a game that involves spinning the wheel, a money wheel shown. Drawing, or during your turn, you get to spin the wheel twice. What is the probability that you will get more than 500 on the first spin and then go bankrupt on the second spin? So to save time on this, we've marked all of the ones that have more than $500. So, and I will tell you right now that there are 24 total spots on there. So the probability of getting more than 500, we find out is 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 out of 24 chance of getting more than $500. And then there's that word and. So then, and then we're going to go bankrupt. And there's only 2 bankrupt spots. But remember, it's still out of 24. And the reason that it's out of 24 is because I can still land on one of those other spots. We didn't take it off of the money spinner. So if we do some canceling, I find out that I have a 1 out of 36 chance of getting more than $500 and then hitting bankrupt. Okay? All right, so example number 4, and this will actually be our last one. It says, during the 1997 baseball season, the Florida Marlins won 5 out of 7 home games and 3 out of 7 away games against the San Francisco Giants. During the 1997 National League Division Series with the Giants, the Marlins played the first 2 games at home and the 3rd game away. The Marlins won all 3 games. Estimate the probability of this happening. Well, the probability that they won the games at home were 5 out of 7. Probability they won the away games was 3 out of 7. And we know that the first 2 games were at home. So in other words, the probability they were going to win the first game was 5 out of 7. Times, there's no or in there, the probability they won the second game, home game, was also 5 out of 7. And then they went away, and there's that word and, so it means we're going to multiply. Then we're going to win 3 out of 7. And then we simply multiply. 5 times 5 times 3 gives me 75. And 7 times 7 times 7 gives me 343. Okay? All right. So a couple things you just have to remember when you see the word and. So as a lesson recap, that word and in there refers to the fact that you're going to multiply. Okay? All right. Good luck.